It is pitch black over the Red Sea. A radar operator spots a target skimming just above the waves, heading straight for the ship. The incoming weapon is an Iranian-designed Shahed drone. It is a simple, propeller-driven airframe packed with explosives that costs $20,000 to manufacture. The ship's automated defenses react instantly. A silo opens and a highly advanced interceptor missile erupts from the deck, destroying the drone miles before impact. The crew is safe and the ship is safe. To destroy a $20,000 drone, the Navy fired a missile that costs over $2 million. They won the physical firefight, but they suffered a severe economic defeat. For the last 70 years, modern militaries engineered their air defense systems almost exclusively to counter high-end, highly complex threats. They built interceptors to shoot down supersonic jets, stealth bombers, and ballistic missiles. This visualizes the cost-exchange ratio, which is severely inverted. Intercepting a modern drone swarm costs over 100 times more than the attack itself. Every shot fired is an unsustainable budget trade-off, effectively trading millions of dollars for targets cheaper than a used car. High-end defensive shields have created a vulnerability where extreme sophistication is defeated by simple financial exhaustion. This transition became visible during the 2020 Nagorno-Karabakh conflict. Multi-million-dollar, heavily armored tanks were systematically destroyed by loitering munitions, suicide drones designed to circle a battlefield and strike vulnerable top plating from above. Decades of engineering designed to make tank armor impenetrable from the front is negated if a cheap threat bypasses those directional defenses entirely. In March of 2026 alone, Ukraine reported shooting down over 33,000 incoming drones. That is a monthly volume that drains multi-million-dollar missile magazines at a speed no Western defense budget was designed to handle. Victory no longer requires destroying an enemy's launch platform. It only requires exhausting their limited supply of interceptors. Iran has built its military doctrine around this principle, mass-producing cheap suicide drones and distributing them to regional proxy groups. These forces can launch precision weapons from the back of a flatbed truck. When those drones target international waters, they face high-tech naval destroyers. But a warship has a hard mathematical limit. It can only carry a finite number of interceptor missiles in its magazine. Once a ship empties its expensive missiles against a wave of cheap drones, it must leave its post and sail back to a friendly port to resupply. The flaw lies in using these limited, high-end interceptors as the default net to catch low-end, propeller-driven threats. Defense systems designed to stop a handful of elite weapons are mismatched against a threat landscape defined by thousands of cheap ones. This animation shows the sensor problem defenders face. Advanced radars are engineered to track high-speed fighter jets. They struggle to maintain distinct locks on massive swarms of small, slow, low-flying fiberglass targets cluttering the screen. Even if the radar tracks them all, a physics bottleneck remains. Defense contractors cannot physically manufacture complex interceptor missiles fast enough to replace what is fired at the swarm. In a prolonged conflict, victory favors the side with the greatest mass manufacturing capacity, regardless of their technological lead. The next superweapon may not be the most advanced. It may simply be the cheapest thing built.